All right, so we are going to make a sinusoidal equation for this Ferris wheel. So as you do this, one of the first things you're going to start thinking about is the highest point and the lowest point and the middle of the graph. So it's a Ferris wheel, it's 3 feet off the ground, so that's going to be the lowest point that it goes. Diameter of the wheel is 108, so it's going to go 108 feet higher than the lowest point, so it's going to go all the way up to 111. And that means that the middle of those two numbers, 111 plus 3 divided by 2, that's going to be the middle, is 57. So if you know the middle and you know the highest, that means you also know the amplitude, because the amplitude is how it's going to go from the middle to the highest point or the lowest point. It's be 54. So you've actually got half of the equation already because you know the midline and you know the amplitude. We need to know the phase shift and we need to know the period so we can find B. So it takes 38 seconds to get to the top after the last car is filled. So at 38 seconds, we start at the top. And then you make a full revolution, so you go all the way down and back up in every 2 minutes, which would be 120 seconds. From there to there, which is the period. So formula for period equals 2 pi over B. In this case, we just said the period was 120. So 120 equals 2 pi over B. So B equals 2 pi over 120. Or reduce that to be just pi over 60. So we know amplitude, so we know A. We know B, that's what we just found. We know C, because that's the starting point, and we know D, that's the midline. So that's it. We've got our entire equation. The only thing we didn't explicitly talk about is the shape. And you got to decide if that's a positive or negative sine or cosine. And since it starts at the top and goes down, that would be a positive cosine. We have a positive cosine that starts at 38 with all that other info. So A is the amplitude, 54 cosine. And then B would be the pi over 60. X minus the shift to the right 38. And then plus midline would be 57. All right, so we type it into our calculator. Make sure your calculator's in radians because this function's in radians. And there we go. Check radians real quick. Radians good. And we need our window to match the graph a little bit. So we made a sketch of it so we can change our V window. Looking at this, I see that our Y's go from like 3 to 111. Our X's might as well start at 0, but it goes out for several minutes. And we did our X's in seconds. So if we went out for, let's say, 10 minutes, that'd be 600 seconds. So we're talking about going around 2 minutes. It takes 2 minutes to go around, so that might be enough. And here it talks about 5 3/4 minutes. Our y's, we said it's got to be at least 3 to 111. I'm going to do 0 through 120. Whoops. Just because those are easier to type. So once you get your window set, you see the graph. It looks like it should. Right up here at the top, that's where we started at the 38 seconds, or at least it should be. That should be 2 minutes, 2 minutes, 2 minutes, 2 minutes. That seems to make sense. How high will you be after 5 3/4 minutes? So 5 3/4 minutes is 5 times 60, and then plus 3/4 of a minute, which would be 45 seconds. So 5 times 60 plus the 3/4 of a minute is 45 seconds. Or you could have done 5 3/4 times 60. That would have worked out too. That's 345 seconds. Going back to our graph. How high will we be? That's going to be a y calc when x is 345 seconds. Not very high. We're down there at the bottom somewhere. So one thing I want to remind you of is, even though I can't see that right there, that is our y value. So you can manipulate this. You can make it work out so you can figure it out. Or you can just go back to your main calculator and type y. There it is. Same thing, because it stores those values as x and y whenever you do that. So how high will it be? 6.587. Which makes sense. We are down towards the bottom, and the bottom's at 3. When will you be 80 feet off the ground going down for the 10th time? I think we need to extend our graph out, because I don't think this shows 10 times. Going down for the 10th time. So this is going down for the first time, up, down second, down third, down fourth, down fifth. So there's a couple ways to do it. You can extend your graph, or you can just keep adding on 2 minutes, because you're going to be at that same spot every 2 minutes. It's up to you. But that's a when, so that's an x calc. And we're 80 feet off the ground. So if you look at this going down, so that's 59.59. And then going down again, that should be 2 minutes later than that, 120 seconds later. Going down again, that's another 120 seconds later. Going down again, that's another 120 seconds. So you can keep adding on 120 seconds, or you can extend your graph out long enough that you can count 10 times over. So we'd have to extend this out. Instead of 600, it's probably going to be more like 1,200. X calc, Y is 80. The thing you have to be careful about is with the wording, since it does say going down, this first one we're going up, we don't count that. This is going down for the first time, going down for the second, third, fourth, fifth, sixth, 7, 8, 9, 10. And that's our x value. So again, if we go back to our main calculator, we type in x, we get that value. We should probably change that into minutes, though. So to change that into minutes, let's divide by 60 to figure out how many minutes that is. 18.99. So basically 19 minutes. If you want to be a little bit more precise, you would then subtract the 18 minutes from it, multiply that leftover part by 60, figure out how many seconds that was. So it's 18 minutes, 59.6 seconds, but 18 minutes, 59.6 seconds, but you might as well say 19 minutes, because that's going to round up no matter what.